Okay, so now we talk about removable discontinuity. So let us draw a curve y is equal to fx. The curve basically has a hole. And the point x is equal to 7. Okay, I'm drawing a hole here. At x is equal to 7, which corresponds to y is equal to 5. Okay, so now if I have to take limit at x equals at x tends to 7, I can always say limit x tends to 7 fx equals 5. Value of y is 5, right? Now let me mark one more point on the graph at x equals 7. So when x is exactly equal to 7, I mark a point on the graph, and this corresponds to y equals 3. So here again I can say that f of 7 equals 3. Now since limit x tends to 7 fx, which is 5, is not equal to f of 7, which is equal to 3, therefore I can say that this function is discontinuous. Now supposing I create a situation wherein I shift this point up, I fill this hole and I shift this point up such that my f7 now becomes equals to 5. Earlier f7 was equal to 3. Now by making some changes in the function, I made it f7 equals 5. Okay, so what happens now? Now my function becomes continuous at the point x equals 7, right? So limit x tends to 7, f of x equals f of 7 equals 5. So now my function is continuous. So I made a discontinuous function as continuous, right? Now let us take a practical example. Okay, let's have a function here fx equals x square minus 44 for x not equal to 7 and is equal to 3 for x equals 7. Okay, now if I want to take a limit of this function at x equals 7, okay, let me take limit of this function, limit x tends to 7, x square minus 44. So basically what I'm doing is I'm just plugging in the values of 7 and getting a value of y, right? So when I plug in 7 in this equation, it becomes 7 square minus 44, 49 minus 44, this becomes equals to 5, right? So limit x tends to 7 f of x for x not equal to 7 becomes 5, right? This is what I got earlier also. X tends to 7, f of x is equal to 5. But now what is f of 7? F of 7 is nothing but 3, which is given in this equation. Right? So f of 7 is 3. Now since these two are not equal, that is limit x tends to 7, f of x is not equal to f of 7, and this function is discontinuous. Okay. Now if I alter this function like this, okay, so I make this fx equals x square minus 44, which is the same thing as earlier for x not equal to 7, and I change this to 5. So instead of 3 earlier, now I have altered the function to 5 for x equals 7. So now what happens at f of 7? F of 7 now becomes equal to 5, right? So now limit x tends to 7, f of x equals f of 7 equals 5. So now I made a function as continuous. Okay, so what I've done is basically I've removed the point of discontinuity, I have altered the function, and I made it continuous. So such kind of functions are called removable discontinuity functions.